Okay, so today we're going to learn how to calculate relative atomic mass. So this is for higher level students only. If you're a foundation level student, just scroll along to the end and it'll take you to the next video in the playlist. So higher level students, firstly, to be able to calculate relative atomic mass, you need to have an understanding of atomic structure, including knowledge of isotopes. Okay, so let's see if you're ready then to move on to learning about relative atomic mass. So from my last video in the series, can you remember what we mean by an isotope for 2 marks as an exam question? Well, if you can't remember or you haven't learnt it yet as you haven't seen my last video, then you need to click on the link in the description below this video. But if you do know what an isotope is, or you have at least had a good go, then let's carry on. So well done if you have said that isotopes are atoms of an element with the same number of protons but a different number of neutrons. So you should also remember from my last video that the number of protons is specific to a particular element. So there are 2 naturally occurring isotopes of chlorine, but they both have 17 protons. So the 2 naturally occurring isotopes of chlorine have masses of 35 and 37. They both have 17 protons, and they both have 17 negative electrons to cancel the charges of the 17 positive protons. So the mass of chlorine 35 is made up of 17 protons and the rest must be 18 neutrons, and chlorine 37 must have 20 neutrons to give a total mass of 37. So what's the definition needed for relative atomic mass? Well, the good news is you do not need to learn the definition. You only need to know how to calculate relative atomic mass, and you do this by taking into account the relative abundance or the percentage of each isotope, and then you are effectively finding the average mass of the isotopes of an element. So this is the information we need to calculate relative atomic mass. We need the masses of the isotopes and we need to know the percentage of each. And this will be given in the question. You have not got to remember any of this information for any element. So think of the information given as being like this. So if you've got 75% and 25%, that's 100% altogether. Think of that as 100 atoms. 75 of them chlorine 35, 25 of them are chlorine 37. To calculate relative atomic mass, you need to find the total mass of the 100 atoms and then divide by 100 to find the average. Answers are normally quoted to 1 decimal place, and this is usually stated in the question. Pause the video while you write down the example. And whenever you do a calculation, you should always ask yourself whether the answer is sensible. So in this case, how do we know an answer of 35.5 is a sensible answer? For this example, we expect the answer to be somewhere between 35 and 37 because those are the numbers that we are finding the weighted average of. And we expect it to be nearer to 35 than 37 because there are more of the isotopes with a mass of 35. Okay, so now it's your turn. I want you to find the relative atomic mass of boron to 1 decimal place. Pause the video while you do that. About if there are more than 2 isotopes. Have a go at this one for magnesium with 3 isotopes. The method is the same. Okay, so well done if you can now calculate relative atomic masses to 1 decimal place and decide whether your answer is sensible. Remember, you don't need to remember a definition, you just need to know how to calculate relative atomic mass. Okay, so if you want more practice at calculating relative atomic mass, or you want some more free resources, then you can go to my website, which is science123.co.uk, and look for the free stuff page on there. For example, there are some trivial pursuit style GCSE questions for biology, chemistry and physics you can download for free.